Heat, thermal energy, and temperature. Heat, thermal energy, and temperature are all related, but are not all the same. Heat and thermal energy are most often confused with one another. While doing research, it is easy to find articles that claim heat and thermal energy are indeed the same. This, however, is not a fact. Heat. Heat is energy that is being transferred between substances. For example, placing a pan on a stove and the stove heating up the pan. This is an example of heat because the warmth from the stove is transferring to the pan, heating it up. Thermal energy. Thermal energy, often confused with heat, is the energy that heat can possess. An object can possess energy but cannot possess heat. Simply speaking, thermal energy is the energy of heat. When heat is added to something, the thermal energy increases, but if heat is taken away, the thermal energy decreases. For example, I have 2 cups of water. 1 cup of water. I filled 1 cup of water with water and ice, and 45 minutes later I went back, and that ice had melted, and there was more water in the cup. When you have a cup of water and put ice in it, the water will heat up the ice, and over time the ice will melt. The cup of water has more thermal energy than the cup with ice. The reason being is that when the cup of water stands alone, it is at a warm room temperature state. Ice is at a freezing state, and when ice is put into the water, it instantly cools the water down. Doing this is decreasing the thermal energy of the water. Temperature. Temperature is measured by kinetic energy. Kinetic energy is how fast particles move. The faster the particles move, the more kinetic energy the substance possesses. Particles move faster when they are hot. This is how we get temperature. The faster the moving particles are, the hotter the substance is. I used a thermometer to tell the temperature of cold water and hot water. I used a candy thermometer so the thermometer doesn't start at 0 but somewhere around 100. As you can see in the first picture, the temperature doesn't even go up to the first line because it's not hot enough, and then in the second picture it goes past 212 because it's at a boiling point. Fahrenheit. Fahrenheit was made by a man named Daniel Gabriel Fahrenheit. The rule of Fahrenheit believes that the point of freezing is 32 degrees, and the boiling point of a substance is 212 degrees. The Fahrenheit system is used in the USA, the Bahamas, some parts of Puerto Rico, and a few others. Celsius. Celsius was made by Anders Celsius. Unlike Fahrenheit, Celsius believes water is at a freezing state at 0 degrees and at a boiling point at 100 degrees. Celsius is used throughout the whole world, excluding the US. Celsius is known and used all around the world and is known as the official way to calculate temperature. Kelvin. The Kelvin unit of thermodynamic temperature is the fraction 1 over 273.16 of the thermodynamic temperature of the triple point of water. The unit of Celsius temperature is the degree Celsius, symbol Celsius, which is by definition equal in magnitude to the Kelvin. A difference or interval of temperature may be expressed in kelvins or in degrees Celsius.